Okay. We're streaming?
Awesome.
All right, here we are, day 1, JEC World, JEC World 2026. I have two gentlemen joining me. I have Wesley Whitaker and Spencer. Spencer, help me out again.
Dansereau.
Dansereau. Okay, say it, get it closer in the mic.
Absolutely. Yeah. Spencer Dansereau, technical founder. And CEO.
All right. And Wesley, what is your title?
Yep, I'm the CFO and co-founder, and I'm on the business side of things.
On the business side. So you guys are working hand in hand. They are a startup booster finalist this year. So one of the exciting startup innovations here at JEC comes from Mach Electric, their company. It's a Boulder-based R&D company and a startup booster finalist, again, that's developing a new way to produce structured carbon fiber directly from CO2 waste. This is really interesting. So I'm excited to have both of these guys on to explain and talk about the technology. Welcome, guys.
Yeah, thank you so much.
So first of all, initial impressions of the show.
Yeah,
this year.
It's great to be here. I think one of the things that's been really exciting is pretty much anybody who's anybody in the composites industry, it comes to JEC. So I think it's great to be here. It's great to have a booth and give a couple presentations.
It's the show to be, right? Exactly, every year.
Yeah, and also it's been great. We've been to a number of composites events throughout the U.S., but actually being in the startup booster program here gives us a place to be, and we've already had people stop by our booth, which has been exciting.
That's great. That's great. And good conversations, I'm sure, already. Yeah. So again, I mentioned you guys are Boulder-based, Boulder, Colorado, University of Colorado. Go Buffs, and
go Buffs.
And developing sustainable, automotive, and aerospace technologies. But this is super interesting to talk about. So we're talking about producing structural carbon fiber from waste gas, CO2, by eliminating the need for. So you're going to have to help me. Polyacrylonitrile.
Yeah. So you can just shorten it to PAM.
PAM. Well, I think of something else when I think of PAM. So all right. So explain this process, the typical process that goes into the making of carbon fiber and what you're doing to eliminate this process.
Yeah, absolutely. So how current carbon fiber is made, more than 90% is from polyacrylonitrile or PAM.
Yeah.
And that's a very lengthy process. There's lots of thermal steps. You start with a polymer and then move through stretching it out. Basically, you cross-link it, pyrolysis, and then you have to reduce that down into carbon. And that takes a lot of energy to do. And so there's quite a bit of actual waste gas that comes out when you reduce it down. And it's a very complex process.
Okay.
And so one of the things that is driving not only the energy amount, it can be over 250 kilowatt hours per kilogram to make carbon fiber, but it's also very pollutive.
Yeah.
It's 20 tons of CO2 to produce 1 ton of carbon fiber.
Wow. And does that, what drives up, obviously we're talking about reducing cost. What's the biggest expense that goes into manufacturing?
Yeah, the precursor, the polyacrylonitrile, is the biggest cost, but followed by the amount of energy it takes to heat the fiber up.
Sure.
It has to go through multiple different thermal stages, well over 1,000 degrees Celsius, and the graphitization stage is even hotter than that. So that's a huge amount of energy as well.
So by eliminating this, you're able to reduce the cost by, what are we talking?
Yeah, so we estimate a 4x reduction in energy and a 7x reduction in CO2 footprint. So we're pretty early stage in terms of cost. So we'd like to talk in terms of energy reduction and things like that.
Reducing your 30% reduction in your feedstock too.
Yes. So we use just pure CO2 for our feedstock right now. Which is really great. We actually take it from a local brewery in Colorado.
That's awesome.
And we just filter out the particulates and water vapor, and then we can make carbon fiber.
That's incredible.
I usually like to add here that though we're currently working with fermentation CO2, that the long-term goal is to work with a cement factory or any kind of pollutive industrial entity.
Okay.
But in terms of, first strides to market, we've been using a brewery in Colorado.
Right. That's a good test launch, in that.
It's a good proof of concept.
Yeah, right. Absolutely. Yeah. And then you can get into the more, why you would want to go more to the concrete, the more industrial scale, is that's where the majority of the volume
of CO2
that you're seeing.
Yeah, and there's also, especially here in Europe, but also in a lot of instances within the U.S. at the state level, there's regulatory pressure to reduce total CO2 footprint in industrial processes.
Sure.
So there's a need for us from the CO2 producers, and we also offer a product that's carbon fiber.
Yeah. So you guys are solving more than just one problem.
That's the goal. That's why we're excited about it.
You're solving multiple problems. So that's amazing. So what kind of you've had conversations at the show? What's been the feedback?
Yeah. So I think one of the pieces that's most exciting for us is that people are really interested in what we're doing.
Yeah.
Even though we're very early stage and coming out of university, that people are interested in it, and it's not only from folks at the end of the supply chain, it's also at the very beginning.
Right.
We won't talk about specific companies quite yet, but a lot of the companies that produce carbon fiber and precursors, things like that, are looking to reduce cost, reduce CO2 footprint, expand capacity, reduce energy consumption, and those are all points that we hit on.
Okay.
And so, and then traction up the supply chain in terms of compounders, end users, integrators, things like that, has been really great here.
Okay.
And like we were saying, anybody who's part of anywhere in that supply chain is here at the JAC.
That's awesome. So I'm sure major, proprietary, the process, everything is, so you're probably going through those stages of getting patent.
So we have a patent through the University of Colorado Boulder.
All right.
We work with an office there, the Venture Partners Office, which has done a great job. But in addition to that initial tranche of patents that we've done with them, we've thought about what it's going to look like to have an external patent lawyer and all of that.
Yeah, right. Definitely would be would be helpful. No, this is amazing. I look forward to following your success, and I'm sure that there will be a following, because this is hopefully just the beginning for you all.
Yeah.
And there's much to follow. I'm sure that you'll be at other shows, CAMX later this year, and
absolutely, Sampi as well.
Yeah, exactly. Well, look forward to hopefully seeing you guys at those shows as well.
Absolutely.
And best of success here at this show. You mentioned the feed. So far, day one's been great.
Yeah, sure has.
Okay, and I hope day 2 and day 3 are great as well for you guys. And thanks for coming by.
Yeah, absolutely. Thanks so much for having us.
Yeah, absolutely.
Catch me at 4 p.m. tomorrow, giving a technical seminar too.
That's right. At the tell them where that's over at the Sampi.
It's at the Sampi Emerging Engineers. Showcase, and so I'll be giving.
So David
wants to know more.
David's one of how many judges? Do you know?
Oh, I think it's. Is it three or 5?
Okay.
It's a handful of judges.
Yeah. Well, he said you guys got narrowed down from a huge. It started out as a big, long list.
Yeah. Well, it's been exciting. So we're in the Sampi Global Emerging Engineering Challenge, as well as the JAC booster program, startup booster program.
Yeah.
So we're doing 2 at the same time, which is really exciting, and our calendars are full. But
that's right.
If you're going to fly to Paris, you might as well have a full
schedule. As well. Yeah.
Guys, thanks so much.
I appreciate you coming on.
Thank you.
Yeah, enjoy the show.
Thanks so much.
Thanks, Wesley.